All right, folks, what I've done here is I've taken all the calculus questions, number 1A, from every calculus exam I could find from 2012 to 2021. And in each case, it's asking you, gives you a function of some sort, and it says, find the gradient of the graph at f, the point where x equals 2. Okay, so that's exactly what I've just basically shown you in the last videos. But I'm going to talk you through this in detail, so there will be no doubt. All right, so here we go. I'll do number 1 for you, and then I'll let you loose on the rest. But do them all, please, because it's just great practice, just going over and over and over the same things until you master them. Yeah. With all of this stuff, you don't do it till you get it right. You do it till you can't get it wrong, and that's kind of the way we go. Okay, so we've got a function which is f of x is equal to 2x cubed minus 10x plus 5. All right, so I'm going to differentiate that. Now, when we differentiate, we're going to find the gradient function. In this case, we've got f, so we're going to say, instead of being f, we're going to find f of x, or f, sorry, in this case, f dash of x. And we call that f prime of x is equal to, now this is where our differential skills kick in, and we're able to say, well, I've got 2 times 3 is 6, so the new coefficient is 6, and I'm going to reduce the power by 1. It's 3 now. Reduce it by 1, I'm going to get a 2. There it is. Minus, well, the power here is going to be a 1, so 1 times negative 10 is going to be negative 10. There it is. I've got an x of some sort, and this is the power of 1. Well, if I reduce the 1 by 1, I get 0. So it's going to be negative 10 times 0. So anything times 0 is just itself. So the x isn't actually there. It's actually just a 1. So we're going to leave that as negative 10. And of course, the 5 on the end just falls away. So that's our gradient function. We've done it. Now it says at the point where x is 2. So if we put the x equals 2 here, we would find the y value for where x was 2. If we put the x value in here, that is in here, we find the gradient at the point where x is 2. So let's do that. So now I'm going to say it's going to be f dash x of 2, if you like. I could rewrite that. F dash 2 equals 6 to, oh, this pencil's dying. Ugh. New pencil. Squared minus, it's falling apart. A lot of smudging going on here. All right, equals, well, 2 squared is 4. 6 fours are 24. Minus 10, and of course 24 minus 10 is going to be just 14. Now 14 what? That's the gradient. That is the m value. So the value of the gradient is 14, which literally means 1 along 14 up. 1 along 14 up. And that's all it means. So you found the gradient where the x value is 2. Now, I'm not going to try and draw this thing, but that's ultimately what we've just found. All right. Now, at the end of this, I get you to do a few other things as well. I say to you, where's the rest of it? What does it say there? I seem to have lost what I'm looking for. Oh no, here it is. Right. At the very end of this thing, I say, in each example above, use calculus to find 1, the turning point for each equation. Now, right now, we've just found the gradient where we've been given a certain value. But if we want to find the turning point, we'll just find the gradient where the gradient is 0. So let's do that now. So we've got, here we were finding the gradient. This was the gradient when x was 2. Now we're finding the x value when the gradient is 0. This, remember, is the gradient, so I'm going to rewrite that. So f dash x is the gradient. And it's called the gradient function, fn. Yeah, f dash x, f prime of x, is the gradient function of, we should put 2x cubed minus 10x plus 5. So f dash, or f prime of x is the gradient function of that equation there, or that expression there, I should say. Now, what we're going to do right now, every time we find the gradient, so remember we differentiated and we said, well, f prime of x was equal to 6x squared minus 10. Every time we put in a value here, an x value, we find the gradient at that point. If I put in 1 there, I find the gradient when x is 1. If I put in -7 there, I find the gradient when x equals -7. If I put in -43 there, I find the gradient when x is -43. But what we're wanting to do is do it the other way round now. This time, we don't want to give it an x value. We want to give it a gradient and then say, what would the value be at that point? Yeah? So let's have a look at that. So in this case, I'm going to say, let's have a look. So I'm going to make this equal to 0. Here it is. Because the gradient, the turning point, is because a gradient of 0. So I'm going to say equals 6x squared minus 10. All right, so I can go ahead now and try and factorize this. And rather unsuccessfully, you're going to have to basically do it on your graphics calculator, or you could use the quadratic equation. And what you'll end up with is a couple of values for x. They will be, notice, not 1 point now, these will be 2 x values for when the gradient is 0. And I'll let you go ahead and do that, yeah? So that is what you're finding. So please do that. Go ahead and just use your graphics calculator, or if you want to use the quadratic equation, you could. Or shall I do that now? Let's have a look. I can do that. 1 second. Sorry, folks. I'm just going to find the... Did I have my graphics calculator? No, I think I left it at school. I'm sorry, I can't really do that one. Okay, and I don't really want to... Oh, no, here it is. All right, so here we go. So here's my graphics calculator. And I'm just going to go menu. I'm going to go 8. And I'm going to go F2 and F1. And I've got a whole bunch of stuff in there which I was playing with. So we want to just clear all that. So I'm just going to go clear. There it is. Now I'm going to put in an x value. So here we've got a value is 6. So I'll put in 6. And we've got, there's no b value, but there is a c value, which is -10. Put in -10. Let's see what happens. And I'll go solve. And I get my 2 x values. So these are the 2 x values. One of them, and I'll just write those out there so you can see them. So we've got x values of, so either I'll put x is equal to 1.2909 or x equals -1.29. So what have we found? We found there are 2 turning points. Yeah, so in other words, this thing is going to be some kind of a cubic. And I hate to try and draw these things, I hate them. But one of the turning points, so I will try and draw it, here we go. And it looks roughly like this. So it's going to be about like, so one of the points is going to be this point here, which is -1.29. And this point here is going to be x is 1.29. These are the x values, yes? So now I have the 2 x values when the gradient is 0. So we found the 2, if you like, turning points. They're the x values of the turning points. Now, of course, we want to find the y values as well. So what you can then do is you can say, we've got the equation, and I'm not going to do this for you now. I'm going to let you go ahead and do that, and say we've got the equation, which is, in this case, f of x is equal to 2x cubed minus 10x plus 5. Now, we're going to put in this x value here into there and there, and you're going to come up with a certain y value. Then you're going to put in this value here into the same things here and here. And you're going to come up with another y value. In doing so, you're going to have the ordered pair. You're going to have the coordinates. So I'll just do this bit for you. So we've got the x value, which is going to be negative 1.29, comma, and your job is to find the bit that goes in there. And this one's going to be 1.29, comma, and the bit that goes in there. And that's all you need to do.